Alright, welcome back to Algebra 1 class. I hope everybody had a really good Easter, celebrated the resurrection of Jesus Christ, and now it's back to schoolwork. And unfortunately in Algebra 1 we're kind of at the same place that we were last week in Algebra 2. We're in the midst of radicals. The good thing for you guys is this is not near as hard as the Algebra 2. So if you watch any of the Algebra 2 videos, they can be applied to this. The problems will just be a little bit harder. This is on pages 287 to 288 if you are in my class. And it spans 2 lessons. I broke it up into 2 lessons, but I'm only going to make one video for both lessons. So there will be a few more problems I want to do with the FOIL method after I do these on the board. I realize there is a glare in this area right here. I'm going to try not to write it on it. I've been trying to figure out ways of lighting this up a little bit better, but until I can get out to some place like Lowe's or order something off of Amazon, I haven't yet to everything would come up with looks worse. So I apologize for the conditions, but hopefully you get the math, not necessarily the quality of the video, the quality of me. I'm looking pretty atrocious today. It's very windy outside, so not that that helps my looks or discounts my looks, but I got a dad joke for you, I guess. My dad told me this morning on the phone, he's been calling and checking in with things going on, make sure everybody's safe. And he said, why do geese fly north for the winter? And I'll do a dramatic little pause right here and let you try to guess, why do geese fly north for the winter? You ready? It's a dad joke. Ready? Because it's too far to walk. Won't. Yeah. Alright, so anyways, let's get on to math. Algebra 1, I don't know if I got to do any of your videos where I told you that if you write down everything on the board on my videos and turn it in with the work that corresponds with, so when you turn this in, if you write this down and staple it to it or send it with it and put video work, it'll be extra credit for each one. That way I can help you keep your grades up as best possible. We are coming up on finals here in about 3 weeks, so that extra credit will be nice. Alright, we're going to jump back in. Enough of me rambling on here. So radicals and multiplication. Multiplication is actually easier than adding and subtracting. Just like in fractions, multiplication is easier. And that's because you don't have to have a common radical. That means the number inside does not have to match. The numbers on the outside, like the roots, the orders, or the index, they have to be the same. Like these are both squares. These are all cubes. Those have to be the same, yes. But the radicals themselves do not. As where you add them, these have to be the exact same thing in there in order to add them, which poses a little bit of a problem. So these are a little simpler than that. They're basic 2 rules. If there's numbers on the outside, you multiply those. If there's numbers on the inside, you multiply those, and then you just reduce them. So we're going to go through here, and if I say radical 6 times radical 7, that's going to give me radical 42, or the square root of 42. Now 42, it does not have a perfect square, but can I break it down into a perfect square and simplify that radical? Well, we need to look at our perfect squares, so we can write a couple of them on the board here to see if any of these help. I went past 42 up into 49. If any of these numbers go in there evenly, it can be broken down. If they do not, it can't be broken down and it stays like that. So obviously 4 doesn't go in there wholly because 10 times 4 is 40. Okay, 9 obviously doesn't go in there as well. 16 doesn't go in there whole times. 25 doesn't go in there, and 36. So this cannot be broken down into a perfect square, so it stays, and that's your answer. All right. When we look at problem 7, I picked this one because it had exponents in there. The rule in algebra is when we multiply things with exponents, we have to add their exponents. So inside this radical, I'm going to go 5 times 3, which is 15. And then this is an x3 and an x6. So that is x to the 9th because 3 plus 6 is 9. All right. Now, reducing this, 15 is not going to have a perfect square because 5 and 3 is the only thing that I can do to multiply to get 15. But x to the 9th, all right, 9 is not an even number. If you want to take a square root out of an exponent, it must be an even number. However, I can break that down, and I could have simplified it right here, but I could break that down to x to the 8th and x to the 1st. 8 plus 1 makes the 9 there, okay? And if I wanted to take out a root, this would be, if this is a square root, which it is, we don't write that, but it's a division problem, so 8 divided by 2 is 4, so x to the 4th would come to the outside. There's a 1 standing here. We do not write it, but it's there, so x to the 4th times 1 makes x to the 4th, leaving me with 15 x to the 1st inside there, and that is your correct answer. Okay. Now we go up here to 14, and again I'm trying to avoid the big blob right here. On 14 I have fractions, so I picked this because there's fractions outside and nobody likes to work with fractions. But fractions are easy to multiply. You can multiply straight across. Even if you don't know how to cross cancel in fractions, you can simply multiply straight across. I can go 3 times 10, which is 30, and 5 times 3, which is 15. And then 2 times 2, which is radical 4. Now that can definitely be reduced. So first thing I want to do, 30 divided by 15, and I'll move this way over here. 30 divided by 15 is 2. So I have 2 radical 4. The square root of 4 is 2. So that comes out and multiplies right here, 2 times 2. My answer is 4 with no radical sign whatsoever. Okay? So don't let fractions scare you, and you have a calculator, so they shouldn't scare you anyways. All right? Make sure all these show on the board. On 24, I picked this one. It has 3. It also has cubes, and it also has numbers on the outside. So it puts a lot of things in there that we need to cover. I'm going to switch colors so hopefully you can see it better. I'll switch to red. I think it showed up. I practiced. The green and the light blue was not showing very good on the video, so I'm trying, but I'm limited to the markers that I have here. So we notice that that's a cube, and that's a cube. That's great. That means we can multiply these without doing anything. All right. We can break these down first and multiply them, or we can multiply them and break them down. There's pros and cons both ways. I believe in the book it says go ahead and break them down first and then multiply them, because if you make an error multiplying them and then you reduce them, you're not going to get the right answer. So we'll go ahead and reduce, and since this is cubes, I'm not taking perfect squares out of there, I'm taking cubes out of there. So if I list some of the cubes, I'll list them on this side of the board. 2 cubed, that's 2 times 2 times 2, that's 8. 3 cubed is 3 times 3 times 3, that's 27. And 4 cubed is 4 times 4 times 4, which is 64. Okay, so that's about as far as I'm going to go, because 64 is the highest number I got in there. Also, pay attention, you have a negative here. If that was a square root, that is a big no-no. It's called an imaginary number, and we haven't dealt with those yet, so you should be scared. However, this is a cube or an odd number out here. It's okay. There is a possibility of negatives. But if I look throughout the whole problem, here, here, and here, there is only one negative number. Therefore, my answer should be negative, and I will explain that here in a minute. Let's go ahead and break these down and make a new problem to multiply. So, cube root of 64, I have it right here. It's 4. So I can cross that out, bring a 4 out here. So I'm going to have a 4. All right, and then I have G5 and H13. Remember what I did right here and split that up? It needs to be a multiple of 3. So I could make this G3 and G2. Okay, 3 goes into 3 one time, so a G would come out here, and that would leave G2 inside. And then on this one, I could make this H12 times H1. 3 goes into 12 4 times, so H to the 4th would come outside, and H1 would be left. So inside here, I would just have G2 and an H. And you don't have to write to the first power. You can if you want to. We go to the next one. And as far as 4, there's no cube root of 4, but I'm going to go ahead and pull that negative out. It is okay to pull that negative out. It's like dividing by a negative 1, which is just going to change this to a negative 5. And then don't forget your little 3 up here. That changes the whole problem. Don't forget your little 3. My 4 is now in there positive. If I applied it back, it would make negative. And G7, I could make that G6 times G1. And 3 goes into 6 2 times. So G2 comes out there, and that one's gone, and I'll leave G1. And then this H, it's to the first power, so I can't do anything with it. It stays in there. Now I'm going to move, and I'm going to have to move these cubes out of my way. On this next one, I have 2, and I have a 10 in there, which is not going to get broken down. The first cube is an 8, and that doesn't go evenly. I have a G to the first power and an H squared. So nothing's coming out there, and I have a little bit smaller numbers and exponents to work with. So I'm going to switch colors one more time. And we're going to go outside, and then we're going to go inside. So 4 times negative 5 times 2. Well, 4 times negative 5 is negative 20. Negative 20 times 2 is negative 40. Okay? That takes care of the numbers. Then I have a G to the first, G squared, and no G out here, so 2 plus 1, if you add the exponents when you're multiplying exponents, that's G3. And then I have H4, no H, and no H, so I have an H4 on the outside. Okay? Now we go inside radical, and I have a G2, a 4G1, I should have did the numbers first, so forget G2 real quick. 4 times 10 is going to give me 40. Now I have G2, G1, and G1, so 2 plus 1 is 3, plus 1 is 4, G to the 4th. And then H, I have H1, H2, and another H2, so that's H to the 4th. I got to move 29 out of the way. I'll rewrite it. But I need the space. So now what I have here is negative 40 G to the 3rd, H to the 4th, times the cube root of 40 G4 H4. But if you look at this, they are not simplified because I can get cubes out of these exponents and out of 40. Remember, 2 to the 3rd power was 8, and I know 8 goes into 40. So I need to break this radical down. So I can break this down into 8 times 5 times G to the 3rd times G to the 1st times H to the 3rd times H to the 1st. Okay, if I look at it like that, that's what I was doing up here, just not that neat. All right, when I come take the cube root of 8, if I look right here, it is 2. That comes out here and gets multiplied. So that's going to give me negative 80. All right, I'll leave some space here. 5 has to stay in. There's no cube root of that, okay? Then 3 divided by 3 is 1, so I'm going to get a g to the first power out there. That one's gone. This g to the first power stays. Okay. H3, 3 divided by 3 is 1, so an h comes to the outside. That one's gone, and this h comes. And that is my final answer on problem 24. Okay. Seemed like a lot of work, and it was a little tedious. But the applications of math are not that difficult. I'm going to do put 29 and then 2 more with FOIL that will be on the rest of the page, and then we'll be done with this lesson. I'll try to do this part. Should have saved my joke for this part because there's a lot of dead air while I'm cleaning off the board. The good thing for us, if you go to our school, our little private school, and you're in my class, you got about 3 weeks worth of actual work, and then review for the final and the final, and then you'll be done with school. So yay for that for you guys. Hopefully all this coronavirus stuff maybe will be out of here by then, and you'll actually get to enjoy your summer a little better. So what did I have? I had 29. Not in this area. I'll put 29 right here. Whoop, that's not a radical. Yuck. And we will do, let's see, 36. And we'll jump on down to 51, I guess. Alright. So, with 36 and 51 and everything in between there, you're pretty much going to use the FOIL method. But before we get there, there's one other application of multiplication, all right, which is like the distributive property, where this is on the outside needs to get multiplied to this and that. So radical 3 times radical 5 is going to make radical 15, and it's a square root. There's no perfect square there, so I can leave it. And then radical 3 times 2, and this is a positive, so my sign is positive. It's just going to be 2 radical 3, because you multiply the things on the outside and the things on the inside. Well, the outside here is a 1, and this outside is a 2, and it doesn't have an inside. And you leave it like that. That's it. You can't do anything else. No, that's false. You can do something. No, you can't. I'm just messing with you. It's got to stay like that. I was going to break this down to 3 and 5, but either way, you still can't pull a square root, so you can't get radical 3 by itself, so ignore me. All right, 36 and 51 and all in between in that area are binomials times binomials. That means there's 1, 2 things, 1, 2 things. Okay, this one too, it's just written condensely, and I'll show you, but that's going to require that FOIL method that we did a few months back, and we spent a lot of time on it, okay? So this squared just means this times itself, so I need to write that twice. I need to write like that, okay? Now that's a binomial, one term, two terms, one term, two terms. They're binomials. This only works for binomials squared. So we're going to FOIL, and I'll use a different color. And the F in FOIL stands for first, so that means the first thing in each parentheses. So 2 times 2 is 4. Y times y makes y squared. Remember, we add those exponents, and those are ones. The O stands for the outside, which would be this one and this one on the outer sides of that. That's negative and that's positive, so this has to be negative. 2 times 7 is 14. There is no y here, but there's a y here, so we have to bring it along. And then we still have radical 5y. Okay? The I stands for the inside, which would be this one. And this one, that is negative and that is positive, so this is negative. That's a 7 times a 2, so that's 14. This one has a y, that one doesn't. And then the 5y in the radical has to come along, so this one doesn't have a radical. So the 5y comes along. And the L stands for last, which would be that times that. That is a negative, that's a negative, so that makes a positive. 7 times 7 is 49, and 5 times 5 is 25, and y times y is y squared. Now we must simplify. That looks like a big mess, but I promise you it's not that hard to sort out. This, if you can recall factoring, which we did, I would say probably maybe a month ago, which there was a lot, but this is a perfect square because I just squared it, which means when you FOIL it back, you're going to get a perfect square trinomial. Those two middle terms will combine together, and that's why they are the same. But I can't do anything with 4y squared. It's staying right now. All right. Negative 14y minus 4, see how these are the same in here, so I can subtract them. Give me negative 28y, not y squared. We're not multiplying this. This is a subtraction problem. Negative 14 minus 14. And then that 5y stays under the radical. And then lastly, I can simplify this. Okay, the square root of 25 is 5. 5's got to come out. Square root of y squared is y. That's got to come out. So 49 times 5 is 245 plus 245y. I brought that y out and that's gone. So my answer is this trinomial, 4y squared minus 28y times radical 5y plus 245y. I cannot combine this one and that one because this one has a y and that one has a y squared, so I have to leave it alone. Okay? That's why I broke this in 2 lessons, that you can do the FOIL on one side and the easy ones before that. Alright, so this one is broken down FOIL, but they're not the exact same in each one, so it's going to be a normal FOIL problem. So again, we're going to go with our first, which would be x squared times 2x squared. That's going to give me 2x to the 4th. 2 plus 2 is 4. On my outside, I'm going to do x squared times the cube root of x. So they're both positive, so that's going to be x squared and the cube root of x. I can't do anything with those right now. On the inside, I'm going to get another positive. Everything's positive in here, so there'll be no negatives. 2x squared times the cube root of x. They just kind of get squished together because they can't be combined right now. And then for my last I'm going to have these two radicals. So that's going to be the cube root, and x times x makes x squared. Now I need to check to see if I can combine anything. This has nothing to go with it, so that comes in the answer. This has the same thing in each radical, so I can add those. So that is like x squared plus 2x squared. That's going to give me 3x squared, because that's 1x squared plus 2x squared. And that just comes in my answer. And then this last one I can't do anything with, because that is an x squared and this is a cube root. If it was a square, I could pull it out, but because it's a cube, I can't. And that's my answer, and I'll leave it alone. It's ugly, and you're not going to know what to do with it, but you don't have to do anything with it, so just leave it. All right, that concludes lesson 287 to 288, which covers 2 days of work for you guys. Have a good rest of your day, and God bless.